Okay, so now let's play with e to the 3x minus 1. So let's start off with just e to the 3x. So that's 3x to the n over n factorial, and that's starting at 0 and going to infinity, so let's be careful with this. So you know that's 3 to the n x to the n factorial. So if I was to write out the first few terms, plugging in n equals 0, I get 1, right? 3 to the 0, x to the 0, 0 factorial you'll know is 1, plus, so then it would be 3x over 1 plus, then it would be 3x squared over 2 factorial, right? And it keeps going. Okay, so always deal with the subtraction first. So e to the 3x minus 1 is like taking away the first term, and that's where n is 0. So I can say I'm just going to take away the first term and get rid of that and start my sum at 1 instead of 0. So 3 to the n, x to the n factorial. Now I'm going to incorporate my x squared in the denominator. So e to the 3x minus 1 over x squared will be 3 to the n factorial, and so then x to the n and x squared down here. So you know what to do with these exponents, right? So this would be the same as saying 3 to the n x to the n minus 2 over n factorial. Now I'm finally ready to take the antiderivative of this. Whoops, and I should be carrying along my 1 to infinity because it matters, right? So if I want to take the antiderivative, oops, forgot my summation sign. 3 to the n, x to the n minus 2, n factorial dx. This turns out to be 3 to the n factorial stays in the denominator, add 1 to this exponent, so that gets x to the n minus 1 and an n minus 1 in the denominator. And I guess I should be putting a plus c, but that's okay. All right, well, one more, and this was like your number 2, or very similar to your number 2 that you had on the assignment you just turned in. So let's start with arctan. So you know arctan of x is n equals 0 to infinity, negative 1 to the n, x to the 2n plus 1, and then 2n plus 1, no factorial in the denominator, right? I'm going to take liberties here. So we have x cubed, right? So arctan of x cubed would be like this. Okay, so let's fix this a little bit. So n equals 0 to infinity, negative 1 to the n. Be careful in multiplying these exponents. 6n plus 3. Okay, so if I was to plug in n equals 0 to look at what the first term is, I would get x to the 3rd power over a 1 plus, right? I'm sorry, minus, because when I plug in n equal 1, it would be negative, right? Negative x to the 9th over 3, right? So I just need to verify, oh, look at that. That is the first term. So to find arctangent of x cubed minus x cubed, let me take liberties here and get rid of this. Don't need this anymore. This would give me, start the sum at 1. 6n plus 3 over 2n plus 1. Okay, now I want to divide through by x squared, and I think we've done enough of these so far, so let me just go right to the integral of this, right? So 2n plus 1's in the denominator, n equal 1 to infinity. So if I'm going to divide through by x squared, right, I'm going to have x to the 6n plus 3 minus a 2. So let's fix that. Negative 1 to the n, x to the 6n plus 1, and then 2n plus 1 down here. Okay, so now let's integrate. So I get negative 1 to the n, x to the 6n plus 2, and this is 2n plus 1, and this 6n plus 2, plus a c, and make sure the sum starts at 1.